What's up, Joel? So today you're going to be still working on inequalities, but we're going to more specifically look at systems of inequalities. And so let's kind of build on that. Same ideas of graphing inequalities, but we just now have two inequalities that we have to graph. And so graphing method. And so what happens here is you're going to have inequality of x plus y is less than or equal to 6 and 2x minus y is greater than 4. So just like systems of graphing, systems of elimination, systems of substitution, you're always going to have two equations with these. And so before we graph them simultaneously, let's look at them separately. So I always like to graph them on their own first and then look at them in comparison, right? So with these, I highly recommend that you use two colors, two completely different colors, so you can see the difference between the two. So if we graph this one again, make sure you put it into y equals mx plus b form. And you're going to get something like this. And you would have a solid line shading everything below because it's less than or equal to. And then you're going to go ahead and graph the next one, okay? So once you have both of them graphed on the same coordinate grid, you can now ask yourself, so what happens when we graph both of them, both inequalities simultaneously? And let's see what happens and what this means for our answer. And so coolness discovered, I love these kind of systems of inequalities because looking at both of these, we automatically find that our solution to our system is the brown area. And what this brown area is, it's where our two shaded areas coincide. So that's where they meet. All the solutions in that brown area will always be solutions and answers to both of our inequalities. And so the green region and the red region are outside the solution set. So therefore, anything that you see as the same, so like the green would not follow the red solutions and the red would not follow the green solutions. It's only that brown area that is our answer. That's what we're looking for right there. And so what are our steps? There's a lot of steps to this. So first, graph first inequality. Shade lightly or use colored pencils. I like using colored pencils. I have some if you need some. Graph second inequality, use a different color, or you can shade lightly. And then shade darkly over the common region of intersection. So you can use a different color, or you can just shade darkly with your pencil for that common area where they both meet. That is your solution. And so graphing systems and inequalities. We've talked about a lot about this. So let's review everything and we'll practice. Write inequalities in slope-intercept form. You use the slope and the y-intercept to plot the lines. Graph in the line. So use a solid line for less than or equal to or greater than or equal to. Use a dashed line for less than or greater than. Pick a point above the line or below the line. Test the point in the inequality. If it makes the inequality true, then shade the region that contains that point. If the point makes the inequality false, shade the region on the other side of the line. Or, okay, you can remember what I talked about, that if it's a greater than or greater than or equal to, you shade it above. If it's less than or less than or equal to, you shade below the line, okay? But you can always pick a point to see if it works as well. So systems of inequalities, follow steps 1 through 4 for each inequality. Find the region where the solutions to the two inequalities would overlap, and this is the region that you should be shaded, okay? So let's look at some examples here. We have y is greater than or equal to 2x minus 4. Y is less than negative 3x plus 2. You're going to use the slope and the y-intercept to plot the 2 points for your first inequality. Okay, so we're going to plot those points. Draw in the line for greater than or equal to. Use a solid line. Pick a point to test if it is where the shaded area is, but we could also just say we're going to shade above, right? Because it is a greater than or equal to line. Or you can use a point, 0, 0. Now do the same for the second inequality, right? So use the slope and the y-intercept to plot the points for the second inequality. You have there and you have there. Draw in the line for less than, use a dashed line because it's a less than sign. Pick a point and test it in inequality, shade the appropriate region, or you can just know that it's less than, so you're shading below. And then we need to find that shaded area that's in common. So you have here for the first line. Oops, sorry. And then, of course, you're also going to have this area here as well for the blue line. So this is our answer right here. This would be our final answer right here. All right, Joel.